Hello everyone and welcome back to the third part of the NPC Dialog system tutorial. Let's get right into it. Before adding new functionality to our dialog, I want to improve an important part of our logic. Right now, we set the focus distance of the NPC and player cameras manually. But this quickly becomes a problem if another NPC uses a different camera position, angle or distance. Also, animations can move the face out of the focus area we defined. A better solution is to automatically calculate the camera focus distance so the face stays sharp no matter where the camera is placed or how the head moves. You might think about using camera tracking now, but focus tracking only works with actors placed in the level, not with components inside a blueprint. So instead, we calculate the focus distance ourselves. Open the dialog blueprint and create a new custom event called Set Camera Focus. Drag in the NPC reference and get both the NPC camera and the player camera. We also need to access the face component of the character. Let's start with the NPC camera. Get the world location of the NPC camera and from the face component add a getSocketLocation node. When using a Metahuman, the socket name is facial_C_nose. This socket will be our focus point. Now, subtract the socket location from the camera location and calculate the vector length. This value represents the distance between the camera and the face, which is exactly our focus distance. Drag off the NPC camera and add a Set Focus Settings node. Split the focus settings pin and connect the vector length to the focus distance input. Connect the custom event execution pin as well. Now we repeat the same process for the player camera. Get the player camera world location. Add a getPlayerCharacter node and cast it to your player character blueprint. From there, get the face component again. Add another getSocketLocation node using the same socket name, facial_C_nose. Subtract both vectors, calculate the vector length, and connect the result to another Set Focus Settings node for the player camera. Finally, connect all execution pins and call this event right after the camera switch event. Now both cameras will always stay perfectly in focus. Okay, now we can set our focus back to the dialog itself. Open the dialog widget and go to the event graph. Create a new variable. This will allow us to switch between the text lines. Make it an array variable of the type TextObjectReference and name it Dialog Lines. Next, create a custom event and name it SetDialogLines. Drag the new variable into the graph and add a clear node. Then add a makeArray node and create 4 pins. Drag all 4 text components into the graph and connect them to the array pins. Finally, connect the clear node to a SetDialogLines node, using the output from the makeArray. This setup gives us a simple index-based system to choose which lines should be highlighted and which should not. Then create another custom event and name it HighlightText. Add an input to it. Name it Index and make it an integer. Drag the dialog lines array to the graph. Drag out and get a copy. Then connect the integer you just created to the index pin. Now drag out and search for Set Color and Opacity. Connect the execution pin of the custom event to it and split the In Color and Opacity pin. Choose a color you like for the highlighted text line. Do the same thing with another custom event named Black Text or whatever color you use for the unselected text lines. Compile and open the dialog blueprint. To easily call events inside the widget, create a new variable, name it widget and set its type to our dialog widget. Set this variable at the end of the open-close widget section. Then, right after calling the camera switch event, drag in the widget variable and call the set dialog lines event, followed by the highlight text event. Leave the index at 0 so the first line will always be highlighted when entering the dialog. Now let's quickly add the input section to toggle between the lines. Create two new integer variables. Name one current line index and the other one nav direction. Add the keyboard inputs down and up. Because inputs are always active, we need to make sure we are in the dialog. Here we can simply check if the character's move input is ignored or not. We will need that state for any input we use, so let's quickly create a small function that gives us the state at any time. Create a new function and name it inDialog. Get the player controller and add an isMoveInputIgnored node. Select the inDialog node and add an output. Name the output also inDialog and leave the type set to Boolean. Connect the return value of the isMoveInputIgnored node to the inDialog pin of the return node. Compile and save. Back in the event graph, we can call this function anytime we need the inDialog state. Add one after the down key input and one after the up key input. Add a branch to each of them, and if the condition is true, set the nav direction to 1 for down and -1 for up. Drag in the widget reference, call the black text event and connect both execution pins to it. For the index, connect the current line index variable. Then add the nav direction variable to it. Add 4 to it and add a modulo node, which is simply the percentage symbol. The modulo node ensures that if the index goes above the last line or below 0, it wraps around automatically. Adding 4 before the modulo guarantees that negative numbers loop correctly. Use 4 as the b-value because we have 4 text lines. Then set the current line index variable with result and call the highlight text event from the widget. Finally, set the current line index back to 0 at the end of close widget to make sure every time you enter the dialog the index is on the first line. Now we can toggle up and down the lines. But at the moment, we are still using dummy text lines. To keep the system flexible, we don't want to hard code any text directly inside the blueprint. Instead, we create our own data table that can be customized individually for each NPC. Right-click in the content browser and search for a structure. Name it NPC structure and open it. Select the existing variable and name it active lines. Set the type to text and enable the array option. Then hit save. This structure will later hold all dialogue-related data for each NPC, such as text lines, camera settings, animation references, or additional dialogue flags. Now right-click again in the content browser and create a data table. When prompted, choose the NPC structure we just created. Open the data table and press the plus button to add a new row. Name this row Default Lines. Inside the Active Lines array, add 4 elements and enter the first dialog lines you want to display when entering the dialog. For example, how are you today? How is the weather? Do you have a quest for me? And I have to leave now. Save the data table and open the dialog widget. Switch to the event graph and create a new variable called NPC Data Table. Set its type to the data table object reference. To allow this variable to be set from the dialog blueprint, enable Expose on Spawn and Instance Editable in the Details panel. Now open the dialog system blueprint and go to the Open Widget event. You'll notice that the Create Widget node now has a new NPC Data Table input pin. Create another data table variable here, compile and set its default value to the data table we just created. Drag this variable into the graph and connect it to the new data table pin. This way, every NPC can use its own data table, which is then passed directly to the widget. Now let's add the default lines to the screen. Open the Dialog widget and go to the Set Dialog Lines event. Here we add some logic. Drag the NPC data table into the graph and add a Get Data Table Row Names node. Add a For Each Loop node, followed by a Get Data Table Row node. The row name is the array element, and the data table is our NPC data table variable. Drag out from the Out row pin and add a Break NPC Structure node. We now have the text entries from the data table. Drag out and add another For Each Loop node. Finally, bring in the Dialog Lines variable. Get a copy of it, connect the array index to the index pin, and drag out from the output pin to call setText. Connect the array element pin to the text pin. To make sure all text lines start with the unselected color when entering the dialog, drag out from the output pin again. Add a Set Color and Opacity node, split the pin and set the color to your unselected line color. Compile and save. Now our first dialog line set up for the conversation is ready. In the next part, we'll add line selection and the NPC's reaction, including audio and animation. That's it for today. See you in the next part. Cheers!